Hello and welcome back to our series about the spatial crime perception gap. This is our third and for now final study on this topic. My name is Alexander Bressler. I am a co-author on this study and I will be presenting to you in brief what this study is all about. I will be telling you about what we were researching, how we gathered the data and how we prepared it, and finally I will be telling you about the results. Once again, as it was the case with the other videos, this is just a quick introduction to the topic. More detailed discussions and explanations can be found in the corresponding paper. You will find a link to it in the description below, once it has been published. The aim of this paper was to figure out if there are any individual characteristics that make people more or less likely to accurately identify safe and unsafe areas. We know from existing scientific literature that individual characteristics and experiences can play a big part when it comes to fear of crime, but fear or worry does not necessarily translate to accuracy. So specifically, we wanted to find out how feelings and experiences relate to accuracy in crime perception. We also checked if demographic data and socioeconomic factors are related to accuracy. And finally, we wanted to compare our findings between Vienna and Budapest. To answer our questions, we employed binary logistic regression. We built a logistic regression models and looked at how much each variable influenced a binary outcome of either accurate or inaccurate perception in an area. How did we gather and prepare the data? The data acquisition happened via GeoQuestionnaire. The participants could indicate areas where they felt safe or unsafe and also answer questions about themselves. It's the same questionnaire we also used for the first two studies, but this time the focus lies on the data about the participants themselves. Also, once again, we are using the same crime data as in the previous two studies. The next step was to combine the personal data and the crime statistics. From the geo-questionnaire, we got a bunch of polygons, and the crime data was used to calculate crime hotspots. Side note, crime hotspots in this case does not refer to some super dangerous no-go area in the city where you will get stabbed and robbed. It's just places where more crimes were reported than elsewhere in the city. So we overlapped the polygons and the crime hotspots to determine for each polygon how much they overlap. And since people could draw multiple polygons, we calculated the average overlap per person. This overlap can then be easily translated into accuracy percentages. If, for example, a person drew one unsafe polygon and it had an 80% overlap with a crime hotspot, it would be considered 80% accurate. If a person drew the same polygon but marked it as safe, it would only be considered 20% accurate. That's how we get our accuracy percentages. The main part of our research, however, is binary logistic regression, so we need to turn the accuracy into a binary value. In our case, we decided that a person with an average accuracy percentage of 60% and more would be considered accurate. 40% and lower would be considered inaccurate. And here we can see what our data looks like. These are individual polygons separated in color based on whether they were accurate or not. As mentioned before, for our regression model, we don't really use the polygons themselves, but the people who drew them. This is just for the sake of visualizing our data. Now we finally get to the results, and I'm gonna start with the perceived safe areas. We can see that both in Vienna and Budapest, gender is a statistically significant factor. But interestingly, we see inverse effects. So while in Budapest, men were more likely to accurately identify safe areas, in Vienna, men were less likely to do that. In Vienna, also interestingly, people who often feel unsafe were less likely to accurately identify safe areas. So in other words, people who feel more unsafe in general also had a higher tendency to overestimate the safety of certain areas. In Budapest, we could also see that people who have been living in the city for longer were more likely to accurately identify safe areas. With that being said, unfortunately, the model for Vienna is not performing as well as one would hope. We had a smaller sample size for that city, which is also the reason why we have fewer variables here. We also ran some more models with different parameters, and the results remained more or less the same, so we are fairly confident that the results here are still overall meaningful, but for the sake of transparency, it has to be mentioned. Looking at the unsafe datasets, we once again see that for Budapest, the time lived in the city is relevant. But this time the effect is inversed, so overall in Budapest, people who have been living in the city for longer were more likely to accurately identify safe areas, but were also more likely to overestimate the dangers of other areas. In Vienna, we can instead see that people who believed crime to be a bigger problem in the city also tended to overestimate the danger levels of certain areas. Interestingly, however, people who have experienced property crime were more likely to accurately identify unsafe areas. This time, the logistic regression model for Vienna is also performing much better, meaning that the results are overall more significant. What does that tell us about our original questions? Well, it turns out that first of all, accurate crime perception is related to different factors between cities. Also, different factors are relevant when assessing safe and unsafe areas accurately. Overall, we see a trend that in Vienna, personal experiences and opinions seem to matter more than demographic or socio-economic factors. Conversely, in Budapest, demographic factors seem to matter more than experiences and opinions. This may seem strange at first, but it's important to remember that those two are very different cities with different demographic makeups, different crime rates, and they are also existing in different contexts. This leaves us with the realization that yes, individual factors very likely play a role when it comes to accurately identifying safe and unsafe areas in cities. But the impact of these characteristics change from country to country, maybe even from city to city. Another perhaps surprising finding was the surprisingly small role gender and prior crime victimization played. In the scientific literature about fear of crime, gender and personal experiences of crime are often pointed out as key differences, but in our study, which concerns itself with the accuracy of crime perception, we see an overall small impact of those factors. Gender is seemingly completely irrelevant when it comes to identifying unsafe areas, and prior victimization was only significant in one dataset. As you can see, there's still very much to learn and much to research, and our paper is only scratching the surface. Once again, the paper will be linked in the description below once it is published. Thank you for watching.